We KMC RoboPhysicists are a team of 21 undergraduates from Kirurimal College, University of Delhi. The team is divided into 4 subdivisions: mechanical, electronics and communication, science analysis, and outreach and finance. All these divisions have been working according to a tentative schedule drawn during the early days of URC. Now, I'm proud to introduce this year's rover, INFINIT 2. The team made some minor changes in last year's chassis, which was made up of hollow aluminium tubes. These tubes are connected with the help of L brackets. An altered double wishbone suspension system has been employed. The driving motors are directly connected to the suspension arms, and this configuration ensures that the plane of the wheel is always perpendicular to the ground. The arm is an integral part of the rover, having 6 degrees of freedom. The 2 actuators along with the rotating base increases the effective reach of the arm. For equipment servicing tasks, the team will be using a Rero gripper controlled by a cube servo. It has 3 fingers which make it suitable for tasks like turning the valve. During extreme retrieval tasks, the team found parallel jaw gripper to be their first choice, with an ideal dimension and an opening of 134 mm. It was well suited for lifting and holding objects. For sample collection, a scoop with a saw-tooth jaw will be used. The train wheel mechanism makes digging relatively easy even while digging through hard surfaces.
A considerable amount of time was spent to upgrade the electronic components of the rover. The team continues to use ubiquitous Rocket M2 with Air Max omnidirectional antenna at the base and Nano Station M2 on the rover. The team uses 2 different motor controllers, Sabertooth and Citron motor drivers. Last year, the team faced some issues with connectivity and video streaming. However, after reconfiguring the 2 modems, Raspberry Pi is flawlessly handling high-quality video stream. The dynamic nature of connection between 2 modems allows for channel hopping and dynamic resolution for video stream. A major part of electronics team is dedicated to make the rover autonomous. The rover is equipped with ultrasonic sensor, a magnetometer and a GPS module. The rover is capable of avoiding obstacles while moving towards a destination as prescribed. After entering the GPS coordinates of the destination, the rover is switched to autonomous mode. It calculates the heading angle, shortest path and heads towards the destination. In case it encounters an obstacle, the data from ultrasonic sensor is used to steer clear of it. Afterwards, the heading angle is recalculated using the data from the magnetometer. The rover can be programmed to traverse through all the gates once their GPS coordinates has been entered in an array. In case of emergency, we can use these push buttons to switch the rover instantly to the teleoperated mode.
Our science team extensively researched on geology, topography, climatic and atmospheric conditions of Mars. We gathered information about various assorted missions to Mars and even worked in different fields for more precise understanding of Martian science. We made a comprehensive plan for the in-situ investigation as well as for further science analysis, which will be based on the data returned by the rover. The rover is incorporated with various digital sensors to determine temperature, humidity and pH level of the soil. Our lab testing will focus on detection of various biosignatures which are essential for the existence of life. The science analysis includes tests to investigate presence of organic carbon and proteins in the soil. We will also look for the necessary nutrients like nitrogen, phosphorus and potassium.